Okay, back at the pod board, and today we're going to do some pedigree work. Okay, students have been struggling with the pedigrees in class, and so for those who need some help with pedigrees and how to decipher what is what, okay, how to figure out if it's dominant, recessive, we're going to kind of give you some help here. We had 5 questions. Okay, all of the pedigrees that we had in class, the 4 that we worked on the assignment that we did in class, we had 4 pedigrees, 5 questions. Can it be autosomal recessive, autosomal dominant, sex-linked recessive, or X-linked recessive? Sorry, X-linked dominant, or a Y-linked trait. Okay, so we're going to look at this and kind of show you how I would work through one of these pedigrees. Alrighty, so here's what we see. Okay, obviously when we talked about pedigrees, we've got dad, mom, in this case, Big Daddy, right? We got mom. They are both shaded, so that means they are both affected, okay? They have 4 children, all right, and 2 of their children are affected, all right? Now, it might or might not be a big deal that 2 of the daughters are affected and none of the sons are affected. So what we said in class, we said, as we've talked about this, look for patterns. What pattern do I see? I've got a couple of patterns here. Okay, one pattern I notice. Both parents are affected. Okay, they're both affected. 2 daughters are affected. 2 sons are not affected. So I kind of see maybe something that might, in my brain, say, there could be maybe a sex-linked component here. All right, so the first thing I'm going to do, make a table. If you're struggling with this, make a table. Okay, so say, all right, I have to figure out if it's dominant. First thing I do, is it recessive or is it dominant? Could it be both? All right, dominant or recessive? Okay, are my people affected or unaffected? Okay, if it's a dominant trait, so we're not talking sex-linked here at all. We're just saying regular dominance versus recessiveness, autosomal. Okay, so if it's a dominant trait and a person is affected, we have to ask ourselves, okay, what genotypes can they have? If they're affected and it's dominant, they have to be basically one big letter, and the second letter doesn't really matter. Having one copy of the dominant allele makes them affected if it's a dominant trait. So an unaffected person with dominance would be little a, little a. Okay, they are recessive, they're unaffected, they have 2 copies of the unaffected allele. Okay, so let's work through this problem just with dominance. Okay, we said if they are dominant, if it's a dominant trait and they are affected, they must have one big A. So we could go up here and we could write in the possible genotypes of these people that are affected. Okay, all of those affected people have at least one big A. All right? Now, we need to figure out if it's possible for 2 parents who are affected with a dominant trait to have unaffected children or affected children. Okay? So if we do a Punnett square, we'll just draw a Punnett square over here where we have room. There's a lot of crap on this board. Okay, Dad is big A, and we'll just put that he's heterozygous. We'll put Mom, she has to have at least one big A, and we'll put that she's heterozygous. That will matter, okay? The probability of them having affected children, if they are both heterozygous and affected, is 3/4. So they would have a probability of having 3 out of 4 children affected. We don't really care about the percentage here. Okay, all we care about is seeing, do they have unaffected children? Yes. Do they have affected children? Yes. Are both of those phenotypes possible? Yes. So could it be, all right, could it be a regular autosomal dominant trait? Yes. Okay, so regular dominant, that's a possibility. Okay? Now, get rid of our Punnett square. Okay, let's do another one. Let's check out and see if it can be recessive. All right? So if it can be recessive, obviously there are genotypes that the parents or the offspring must be if it's a recessive trait. So if they are affected and it's a recessive trait, they must be little a, little a. Okay? If it's a recessive trait and they are unaffected, they must be at least one big A. Okay? So we're going to kind of look at this and put the genotypes of the people that we know. So if it's a recessive disorder, and these two offspring are affected, they would have to both be little a, little a. If the parents are both affected, and it's a recessive disorder, they would both also have to be little a. Little a. So Big Daddy's little a, Mom is little a, little a. They're both homozygous recessive. Okay? Now, hopefully something just maybe clicked in your brain, I don't know. But if these two offspring are unaffected, they must have one big A.
Can I get Christian Atkinson to the front office, please?
Okay? The question is, where did they get that big A? Neither parent have a big A. They're not carrying one. They are completely recessive. So the possibility of these children getting that big A from either of these parents is impossible. Do a Punnett square 1,000 times. You can't put a big A in a Punnett square from those two parents. So it can't be regular autosomal recessive. That's a big fat no. Okay, so this one can't be recessive. All right? Now, let's kind of change things up here a little bit and ask ourselves, what about sex linkage? Okay, could this be a trait that is linked to the X chromosome or the Y chromosome? Okay, so is it X-linked? That's what we'll start with here. Okay, so we'll say, is it X-linked? Now, there are possible genotypes and phenotypes here. To be affected with an X-linked trait, if it's X-linked, we'll say X-linked dominant. Okay, if it's X-linked dominant, I have a probability of having a female, and she must have one big letter because it's a dominant trait. Okay? Now, to have an unaffected female, she must be little a, X, little a. Okay? To have a male with the trait, obviously the male must be XY, and if he is an affected male with a dominant trait, he must be X big AY. A male who is unaffected must be X little a y. Remember, males only have one copy of the X chromosome, so if it's X-linked, whatever one letter they have makes them or breaks them. Okay, so let's write in the genotypes that we know. Dad is affected. So he must be X big AY if it's a dominant trait. Mom is affected. She must have at least one big A. So we'll write in X big A, X. We'll just make her, when all else fails, make her heterozygous. Okay? So let's see if this is possible to have two affected daughters, okay, and unaffected sons if it's sex-linked. We draw the Punnett square, we put in the parent genotypes. X big A, Y for dad, X big A, X little a for mom. Okay? So they have a probability of having a daughter who is X big A, X big A. They have a probability of having a son, or sorry, another daughter who is X big A, X little a. Okay? They have a probability of having a son who is affected, and they have a probability of having a son who is unaffected. So now I just look at my pedigree and I ask me the simple questions. Is it possible to have unaffected sons? Yes. It's a dominant trait. This son is unaffected with the recessive allele. Is it possible to have affected daughters? Yes, and in fact, all daughters would be affected, either completely or still carrying the recessive gene, but she is affected. This pedigree fits the bill. Both daughters affected. 2 of the sons, even though it says they might have a son that is affected, it doesn't matter. Is it possible to have an unaffected son? Yes. It could be X-linked dominant. Okay? So this is an absolute, yes, it could be X-linked dominant. Okay? Now we ruled out recessiveness on the last one, so we're not going to even test and see if it could be X-linked recessive on this video. Okay? And so on the next video we'll work through another pedigree. All right, kind of in the same way. So if you're still having problems on the next one, look at the next pedigree and we'll look at all of the possibilities. Okay? So that's the end of this one. Hopefully that helped. Laters.